In this video, we're going to discuss the case study based questions on probability chapter. I'll explain the concept needed while we solve some problems. Take a look at the first problem. Here we are seeing a spinning wheel in which 1 to 8 numbers are given. If you spin the wheel, the arrow mark will point to any 1 numbers. Here, all these numbers are equally likely outcomes, which means that each is having equal chances for appearing on the arrow mark. So, every number has equal probability. Totally 8 numbers are there, so each number's probability will be 1 by 8. Let us see the first question. What is the probability that it will point at 8? As I said earlier, each number's probability is 1 by 8. 8 number probability is also 1 by 8. So third option is correct one. Second question, what is the probability that it will point at an odd number? There are totally 8 numbers in which 4 are even and 4 are odd. So we can write it as 4 divided by 8, which is 1 divided by 2. So 1 by 2 is the probability for having an odd number pointed out. Question number C. What is the probability that it will point a number greater than 8? In fact, there are no numbers greater than 8. Up to 8 only we have. So it is an impossible event. Impossible events probability is 0. For your information, sure events probability is equal to 1. Question number 4. What is the probability that it will point at a number less than 9? In fact, all the numbers on the spinning wheel are less than 9 only, from 1 to 8, which means it is a sure event. If you spin the wheel, definitely one of the numbers from 1 to 8 will appear. So as it is sure event, the probability is equal to 1, so second option is correct one. Next, final question, what is the probability that it will point at 0? In fact, there is no 0 at all on the spinning wheel, so it is also impossible event. So the probability of it will be 0. So second option is the correct one. Let us see the next question, in which 3 coins are given, 3 1 rupee coins are given. So these 3 coins are tossed and the outcomes are listed here. Here the winning condition is, if 3 heads or 3 tails are appeared, then the person will win, otherwise the person will lose. Let us see the first question, the probability of winning the game. So it is required to have 3 heads and 3 tails together. Out of the listed 8 possible outcomes, the first and second outcomes are favorable, in which 3 are heads and 3 are tails. So only 2 chances are there out of 8 chances. So the probability is 2 divided by 8, which is equal to 1 by 4. So option 4 is the correct one. Second question, what is the probability of losing the game? There are 6 chances in which the game can be lost. So 6 divided by 8, which is equal to 3 by 4 is the probability for the second question. Third question, what is the probability of getting no heads? You can see, getting no heads means we should not see any edge in the possible outcome. So here only T is possible like that. So that is why 1 by 8 is a probability. Fourth question, what is the probability of getting no tails? Here also no tails in the sense, in the possible outcome, H should be there without any T. So in that way only one possible outcome is there. So that is why 1 divided by 8 is a required probability. Last question, what is the probability of getting one tail? So here you can say I am marking 3 outcomes which are having only one T. That is why the required probability is 3 divided by 8. Let us go for the next problem. In this problem, 5 to 50 numbered cards are given and these cards are actually mixed thoroughly and then kept in some box. Here the events are choosing one card at random from this box. So let us see the questions now. First question, what is the probability that the card withdrawn from the box bears a prime number less than 10? First of all, the prime numbers less than 10 are 2, 3, 5 and 7. So there are totally 4 chances are there. So the probability will be 4 divided by 46. Because from 5 to 50, the numbers are 46 numbers. So that's why I am taking 46 as the denominator. So the final answer is 2 by 23 after cancellation. Second option is the correct one. Let us go for the second question. What is the probability that the card withdrawn from the box bears a number which is a perfect square? Let us list out all the perfect square 9, 16, 25, 36, 49 up to 50. So there are 5 perfect squares. So we can have 5 divided by 46 as the required probability. See the third question, what is the probability that the card withdrawn from the box bears a number which is multiple of 7 between 40 and 50? Here we can see only 42 and 49 which are multiples of 7. So that is why there are 2 chances. So here we will get 2 by 46 is the probability. If you simplify it, we will be getting 1 by 23. So second option is the correct one. Question number 4. Probability of drawing a card bearing a number less than 5. The cards are actually numbered from 5 to 50. There is no card which is having a number less than 5. So that is why it is impossible event. So impossible events probability is 0, we know that. So that's why first option is the correct one. Last question. What is the probability of drawing a card bearing a number from 5 and 50? So all the cards are actually bearing numbers from 5 and 50 only. If you pick any one card, it definitely strikes a number between 5 and 50. So it is a sure event. That is why sure events probability will be equal to 1. So first option will be correct answer for the last question. Now let us see the final question for today. In this question, a pair of dice is thrown and sample space is actually written here. All the outcomes are listed. Let us see the first question. What is the probability that 4 will not come up on either of them? Which means that we should not see the number 4 in any one of the outcomes. So here I am marking where you see 4 as the outcome at least once. So the remaining outcomes are nothing but our required outcomes. So totally there are 25 if you count them. The required probability is now 25 by 36. Second question, what is the probability that 5 will come up on at least one? It is like the exact opposite question for the first question. You can see the marking where we can see totally 11 outcomes are there which involve 5 at least one time. So there are 11 favorable outcomes in this case. So the required probability is 11 by 36. Let us go for the third one. What is the probability that 6 will come up on both the dice? Actually, the last outcome is only the favorable outcome which I marked just now. So there is only one favorable outcome. The required probability is 1 by 36. Let us see question D. What is the probability that both numbers come up are even? Let us mark all even numbers here. In all these markings you can see only even numbers. So there are totally 9 chances are there in that way. The required probability is 9 by 36 which is equal to 1 by 4. And let us see the final question for today. What is the probability that both the numbers come up are prime numbers? Here prime numbers below 6 are 2, 3, 5. So let us list them, the combinations. Then we'll be getting totally 9 combinations. So 9 by 36 is the probability. If you simplify it, we'll get 1 by 4 as the answer. So fourth option is correct one. In the same way, you can do the remaining problems also. In the next video, we'll see another set of case study questions from some other chapter. See you again in the next video.